Welcome to the bonus content of Lesson 8.6. Since the previous section did not contain a formula for an ellipse that was in general form to rewrite it, I thought it would be nice for us to investigate and look for one in the next section of your notes. This does pertain to graphing, and although we have practiced this skill of graphing, I'm not going to require that you practice it today. Today we are focusing on how these graphs translate and also rewriting them in standard form after you identify and classify them. What we're looking for is an ellipse. The easiest way to look for and recognize an ellipse is you're looking for maybe three things. You're looking for an x squared and a y squared in the equation. You're looking for both the signs of the x squared and the y squared to have the same sign, either both positive or both negative. And finally, both the x squared and the y squared have to have coefficients that are different. We're looking for x and y squared, both of them. We want them to be added together or both have the same sign. And then we want their coefficients to be different. Let's go in order. 17, I only have a y squared, not an x squared. That's a parabola. Question 18, I have an x squared and a y squared. I see a plus, but one sign is different than the other. Number 18 is a hyperbola. Number 19, we have an x squared and a y squared added together. Are their coefficients the same or are they different? They are the same. This is a circle. Question 20, I have an x squared and a y squared. They are added together or they have the same sign. Their coefficients are different. Number 20 is the ellipse we are looking for. What I'm not going to do is I'm not going to be concerned about graphing this. I do want to rewrite this into standard form. I'm going to try to complete the squares as best as I can in this white space. Ellipses, we have the x squared quantity plus a y squared quantity, and it equals 1. So let's get started. I'm going to move the x squared terms, or the x terms, next to each other. So the 9x squared minus 54x. Then comes the y terms, plus 4y squared minus 8y, and then I want to move the constant across the equal sign, so I'm going to add 59 to both sides. Not only do I need to complete two squares, but I also have to work around them having a coefficient in front of the x and the y squared term. Let's factor out the greatest common factor. Let's take out a 9, leave room to complete a square. Instead of writing smaller and smaller, what I think I will do is I'm going to just try to do like one at a time. I'm going to remember that I have a 59 on the other side of the equal. If I divide this by 2, square it, and add that number to both sides. If I divide by 2, I get negative 3. Negative 3 squared is 9. What I'm going to do is I'm going to add 81 on the right hand side to offset the 9 9s I added. Next, let's complete the square for the y's. First, factor out the greatest common factor and complete this square. Negative 2 divided by 2 is negative 1. Square it and add the same amount to both sides. I've added 4 1s to the y, so I'm going to add 4 on the other side. Now that this is the left-hand side, and we can combine our right-hand side, it might be easier and I could fit more in here if I rewrite these as binomial squares. And then this is going to equal our constant. What is our constant? So we have 144. Okay, last thing we're going to do. Ellipses always equal 1 on the right hand side. Let's divide everything by 144. So that the 1 is on the right hand side. So let's see, 9 goes in 16 times. And 4 goes into 144 36 times. This is our standard form equation for an ellipse. The center of the ellipse is positive 3 and positive 1. And there you have it. Your homework is a Google form. There are 8 questions. 4 of them are classifying which conic section there is, and also the other 4 questions would be not only to classify them but to state where the center of the graph is. And because you watched the bonus video, I will tell you there is 1 of each in your homework. Good luck.